Okay, hi everyone. Welcome to the closing ceremony for TreeHacks 2023. Thank you all so much for having a great time with us this weekend. We're so happy you were all able to make it. And we just wanted to start off by saying that we're so proud of you. You all spent 36 hours making incredible projects, and we loved hearing and seeing what you came up with in judging. And so last time we started the opening ceremony with a video from our team, but now we're going to have a little video of what all of you did this weekend.
Awesome. Yeah, so besides the technical difficulties, we hope you liked that opening or that closing ceremony video. There were so many cool projects that we saw all throughout this weekend. And I want everyone to, give themselves a round of applause. I think, yeah. We had so many first-time hackers and, a lot of advanced hackers. I think everybody built something cool, but I know why you're all here is to see who won all of the amazing prizes that we have. So we have, over $126,000 in prizes and some pretty amazing stuff. If you checked out the dev post, all the way from electric scooters to Mac Minis and VR headsets. So what we're going to start off with is having some of our highest tier sponsors come up and talk to you about their winners. So first up, we have Protocol Labs. Can a representative from Protocol Labs please come down?
Can I get a shout out to the organizers? This was an amazing event. It's a Herculean effort. We've been to like 3 of these events and we know it's a big lift, so good job, guys. Thank you. So second place, we're giving Mechanical Keyboards for creating a social graph using a home-brewed graph attention network, uploading all assets including metadata stored on Estuary and a beautiful UX. The winners are Course Connections. All right, in first place, we're giving out 10th generation iPads for creating a Web3 console and building decentralized Web3 apps attached to decentralized data, closing a much needed UX gap in the Web3 world, adding encryption and role-based access control. The winners of our first place goes to ControlDB.
All right, so next up we have Palantir. So could a representative from Palantir please come up?
Thank you. Okay. This team impressed us with their transit tracking data application that was built end-to-end in Palantir Foundry. They addressed the public transportation problem in Seattle with 2 great use cases. First, strong data visualizations for city planners to identify data and usage. And second, incentivizing riders to take the subway by showing their carbon emissions saved. This team was ambitious and creative with their technical execution, and we are excited to present them with the Best Use of Foundry prize. Transit Tracker. And also, shout out to runners-up, Team 274 Disaster Management, 198 Given, and 63 Fraud Detection. We were impressed with all of your applications, and we'll be giving you swag bags for your great work.
Awesome. So our next prize is going to be presented by Otsuka Valley Next.
Hi. So, okay. So could you? Before we start, how many people drank Pocari Sweat bottles here? Yes. All right. Amazing. Which are we starting with? Are we starting? So first, for the winner, it was basically a team that focused on a hardware that specifically was able to find the stress levels of muscles through electromagnetic waves, and based on that, they were able to make an app that was designated for finding good food, ways of alleviating your stress levels. We thought it was very highly specialized and innovative technology, and the winner goes to LabVIEW. We also have another prize for Best Connect with Others with the theme of connecting with others through good food. The winner had specialized UI UX design skills that was able to find programming methods of finding, well, if you input specific ingredients or anything left over in your fridge, you're able to find specific types of traditional food that you might be able to connect with other people with, and we realized the kind of potential that kind of specific website and design had. And the winner for that goes to Yuma.
Is a representative from MEM here?
Hi everyone, for the best natural language hack. In third place for their multimodal application of LLMs, Condensis. In second place for creating an application of LLMs that can take action, Mimi. And in first place for some really interesting LLM visualizations, Eddie.
Awesome. Can we have a representative of Convex?
Thanks, Josh. Thanks to everyone who worked on projects this weekend. It's been so exciting seeing everyone work on stuff. There was at least over 30 Convex projects, and we had quite a few team members here, and we just really enjoyed working with people here. It was really fun having people come with questions and chatting and seeing everyone being excited, which is awesome. So we had to choose one winner, and we have 3 prizes going to the winning team, so they're getting a bunch of stuff. And the prizes are too big to give today because they're big. And so we'll ship them to you. And I think it's the people that we said it was going to be, right? Yeah, it's Communipute. All right, and Communipute, really awesome application where you can kind of share your compute resources on the internet. People can go in the cloud and basically write some code and run it on your computer in a Docker container. It was really slick. It was technically very interesting, and it used a whole bunch of Convex features. So congrats, guys. That was really good.
Inner systems?
Wow, that was an amazing weekend. Thank you all so much. There were so many amazing projects. Thank you very much for those who participated in our Inner Systems Challenge. We wish we could award them all, but we did have to pick some winners. We'll start with third place, right? For third place, it was a tie, $1,000 to each to Metabot and Whisker Workshop. Second place prize, $1,500 to Picos Pal. And first place prize, $2,000 for the Inner System Challenge. What? Goes to Forstall. Good job.
Awesome. Do we have a rep from YC?
Hi. Oh no. Did you show the... No. Let's pretend we didn't see that. I want to start off by saying that we were super, super impressed with the quality of all the teams. I think 70 teams pitched to us this weekend. Really, really impressed. It was really difficult to choose just a small number of winners. But I'd like to award 3 runner-ups. These teams were very thoughtful, resourceful, and fast-moving. Some of these teams have already made progress with their startup in the real world, which is really cool. And each of these teams will receive office hours with a YC group partner. These 3 teams were Minuteland, Idle, and Lawn Chair. So 2 teams stood out above the rest, and these winners will receive office hours with a YC group partner, dinner with the YC team, and a guaranteed interview if they ever apply to YC in the future with their real startup. In second place, this team really impressed us with their thoughtfulness, ability to respond quickly to crises, and focus on making an impact on the real world. They've already made a real difference, giving 600 million people access to COVID stats and helping 100,000 refugees and earthquake survivors find shelter, which is really incredible. This team is the internet activism. In first place, the biggest 2 pieces of startup advice that YC gives are 1, make something people want, And 2, talk to your users, which is how you make something people want. And this team did exactly that this weekend. They walked around and talked to sponsors at TreeHacks to discover real user problems and came up with a very real, very commercial idea that I could see us funding at some point in the future. They also impressed us with a very creative and resourceful solution to a known barrier. Congratulations to Woodside. It was really a pleasure to be at TreeHacks, and if any of you are interested in starting a startup one day, you should check out YC Startup School.
Awesome. So we have a representative from Human Cap.
Hey everyone, really great to meet a lot of you this weekend. Wanted to talk to you a little about our Delta Fellowship program that we have applications currently open for online. So a lot of you guys, you took the time to hack and build something now, but if you're in the future interested in turning that into a business, we provide a $50,000 non-dilutive grant to people that are in the process of starting things out. So definitely make sure to check it out on our website. Applications are open on a rolling basis, and look forward to seeing a lot of you guys apply.
Awesome. So now we're going to go through a bunch of our sponsor prizes. We're going to go a little rapid fire because I know a lot of you have flights to catch and buses to catch. So yeah, let's get into it.
Okay, checkbook participation prize. Is anyone that used the checkbook API? You all get a Google Mini.
Awesome. So the best payments hack by checkbook goes to Fresh Buddy.
Best implementation of the checkbook API, winning AirPod Pros, goes to Local.
Best use of the Arduino Cloud API goes to Orange Banana.
Most cyberpunk hardware hack by Arduino goes to Lavu.
Our third place for the Replit Choice Award is Cash Flow. Second place is Picture Pathway. And first place is ShipSense.
All right, the Peak Modal Prize goes to Mixing J's.
Most ethically engaged hack sponsored by the Stanford Center for Ethics and Society goes to Dispatch.
Cotopaxi's Choice Award goes to Grace Pro.
The best use of OpenAI models goes to TBD. So many people submitted projects for this prize that they're still going through them.
All right, big idea. Best use of patient safety goes to Amanuensis.
The second place for the best use of Aptos is Aquajet. And first place, AptoCheck.
Best web front end by Vercel, also TBD.
Best drone hack by Skydio, AIDI.
Best use of Dolby.io is Zazu, AI teaching assistant.
The best use of Supabase, TBD.
Retool Hack Ninja, Carbo.
So for the best dev tool prize by Warp, we have Comnipute. Yes.
BNB Chain, most innovative decentralized application, ControlDB.
And the best use of drone tech by Parrot goes to Express Drone Care.
Best hack using AI ML by Pair, Surge Protector.
Best hack for a real-world use case by pair. Comnipute.
Best hack using frontier tech by pair. Origin.
Best real-world crypto hack by Zeta Chain goes to Vapor Protocol.
Best Omnichain smart contract app by Zeta Chain. Proactive refresh.
The best use of Near Social, sponsored by Near Protocol, is Semantic Near Project.
Best chat app by you.com, second place. Saga. Best chat app by you.com, first place. Talk to History. Best use of you.com, open platform. You care.
The best use of data hack by HRT goes to TBD.
Most innovative hack by Meta. Sense.
And then most likely to become a business by Neo. First plate.
All right, so now we have the TreeHacks prizes. So if you receive a TreeHacks prize, we're going to have these teams do demos of their projects so you can see what they look like. So when we call you up, please come up to the front and we can set you up to present and receive your prize in person as well. So first up, we have the raffle winner. So if you remember, when you all applied to TreeHacks, you could submit referrals and there was a raffle and the winner was going to win an Apple Watch. So we're going to give that one out later, but the Apple Watch goes to Joseph Martinez. Next is our leaderboard winner. So as you all know, we had a leaderboard for attending HackX events, workshops, etc. And the winner of this prize gets TreeHacks custom engraved AirPods. So you can come down to receive it. The winner is Jivan Bata. All right. Now we have Best Beginner Hack winning Audio Technica headphones. And the winner is Fluently.
Give them a round of applause while they come up to do their demo.
Hi everyone, I'm Marina and I'm a sophomore at UC Davis.
I'm Nishi and I'm also a sophomore at UC Davis.
Hi, my name is Shaveen. I'm a junior at the University of Washington.
And my name is Justin. I'm a first year at UCI.
And this weekend we made Fluently. So Fluently is a web application designed to make conversational language easier for communities like refugees, developing communities, and refugee workers. So the idea is that these communities will be going to places where they have to assimilate to their community where their language might not fit in directly with how the other words are pronounced. And so our AI will help personalize feedback so that you can match phonemes to how the rest of the community pronounces it, making it easier for you to land jobs, make friends, and just assimilate easier into the community.
Yeah, so going right into it, right here we have Fluently, amazing design up there with the login button. So let's first start up and log in, and from there we get prompted to this auth0 login, so we can store all our users' data and make it really personalized for their experience as I get through all the passages. So I'm just going to log into one of my many emails. And then as that loads, we just got the auth token from the user and we sent that into our database so that the user can now have a personalized experience when developing their passages and recording their progress. So right here, there's 3 basic functions. There's get passage, record, and learn pronunciation. So learn pronunciation is a text-to-speech, which it tells you what the passage is going to say. So if you need that help beforehand, before you deliver the passage to the computer, you can use that. Or you could use it afterwards to check how well you did. So I just clicked Get Passage, and what we have is OpenAI working on developing a passage for the reader that mixes in different vocabulary words of different complexities to check how well they can pronounce different sounds and develop their speaking overall. So what I'm going to do just now is I'm going to record myself saying the first few sentences of this passage, and I'm going to intentionally say some of the words wrong. So let's see how well the AI is going to recognize which words I say wrong and where it will correct me. It was a sunny day in the park. Jack was playing basketball with his friends when they heard a loud noise. When they looked the other way, they saw a large... So yeah, right now what it's doing is it's actually using Microsoft Azure services and using a natural language processing unit that was actually just developed this month. And it's putting what we just said into that unit and also sending out a process of how well each word was said and how well each word was phonetically pronounced. So at the bottom right here, we have a chart of pronunciation score, completeness score, fluency score, and accuracy score. And as you can see right here, I totally missed soccer. I said a different sport entirely, and I noticed that. But as we look closer into it, we can also see there's different areas in which I've mispronounced loud or a Z in friends, like the phonetics. But also, if we look further, it also checks on whether or not you didn't say a word or not. So we hope to use this program so that we can help people pronounce things better and overall communicate better throughout the future. But yeah, that's the program. Thank you guys.
Awesome. That was an awesome demo. Just waiting for the screen
Gonna take
to come back on. Yep, it's on.
All right, so next up we have the most creative hack, which everyone on the team is winning a Sonos Roam speaker, and the winner is Aqua Shot.
Alrighty, looks like we're good to go. Imagine for a moment a celebrity, whether you hate them or you love them. Let's say that you can shoot a water stream in their face. Right. A personal hero of mine, MTL, I would want to do this to him. So essentially, what we've designed is an opportunity for you to be able to do that while getting basically an autographed video, basically which is going to be this NFT. Now, presenting to you the Aqua shot.
Cool. So basically, the physical part of Aquashot is just this configuration here. It's basically 2 enclosures. Everything here is basically laser cutted, 3D printed, and just assembled all in like 36 hours of the hack. So in the top enclosure, there is our 2-axis assembly with our camera that actually detects movement of the person standing right in front of it. And then attached to this motor, sorry, is our custom-made nozzle that actually increases the pressure of the water, and so that would actually increase the velocity of the water. And then where that water is coming from is actually in this second enclosure, and it actually holds about 1 gallon of water. And so with that, inside is actually going to be a pump that actually takes in the water, and then everything here is connected on a custom-made you got that? On a custom-made circuit board where we have a teensy and 4 transistors along connected with the camera and also the silver motors. Cool.
Yeah, so and I did a lot of some of the software things. So as you can see, there's a webcam, and the point of that is that it tracks someone's face. So I used OpenCV, and for that, it would track the location of one's face and the middle of that face. One problem we did occur was that it can track multiple faces, so we made some decisions in making it like just get one face. So as you can see, if I am standing in front of it, and it locates my face. If I move, it's seeing your face. If I move, it will follow me. It's not following me. But because there's like.
So let's see. I'm right in front of the camera, or I guess Judy is now. So now it's gonna follow Judy here, and so right now, move around, Judy. Yeah. So as she moves, it's basically following her motion.
Yeah, but this is more than just like a camera. As you can see, there was a water pump, and it's more than just a water gun.
All right, so what about the signed recording from MTL? And that's where we implemented Web3 and more specifically Aptos. So here you can see this is our website. And Amy, can you put this Twitch stream in? So on our website, we're planning on making this a way for like creators to interact with their audience members. So you have a Twitch stream on the left, which we just have a phone running that Twitch stream right now. And then you connect your wallet and you click here to purchase a shot. It'll open your wallet, and right now it's going to cost 0.1 APT on the test net. I approve, and it's targeting Daniel over there. And since it was tracking him, it hit him in the body.
All right, our laptops got a little drenched. Oh, no worries, no worries. That was an awesome demo. I love that.
Sorry, guys. Just drying it off.
Nice. Awesome. So our next TreeHacks prize is our most impactful hack. So we'd like to invite on stage CityGo.
Hi everyone, my name is Chloe. I'm currently a freshman at Berkeley.
Hi everyone, my name is Anshul. I'm also a freshman at Berkeley.
Hello everyone, my name's Abinaya. I'm also a freshman at Berkeley, and we're presenting CityGo.
Yeah, so basically what we worked on in the past 36 hours is a tool for urban planners to essentially transform any unwalkable place in SF into a beautiful walkable paradise. And the way we did this was we basically took a heat map visualization of all of the most congested places in San Francisco, rated by pedestrian foot traffic, as well as like car congestion. So we did a bunch of data layering, and then we put that into OpenAI's clip model, which essentially took in that image as well as like suggestions on how to improve the place on an urban perspective. So for example, you could say like improving the sidewalks, making the sidewalks larger, adding more greenscapes, adding parks, or like lively community spots. All of these are factors that were layered onto the image in order to make, for example, like a very congested street in San Francisco into a super nice walkable area. And the reason why we all built this is if any of you guys have visited like Tokyo or France or Italy, it's super walkable. You can walk everywhere, great public transportation. But in America, you really need a car to get to literally every single place. So you need a car to get to like the coffee shop. I'm sure all of you guys have like driven to school before, but there's really no option for like most of Americans who are not living in like NYC or Boston to walk to any place. We basically need a car for everything. And so we really wanted a way for urban planners to detect like, okay, here's the exact street intersection that has like the most unwalkable, most congested areas. Congregate all of that data together and then make it super specific granular data on exactly like where that unwalkable area could be. The current problem is a lot of these urban design tools are super arbitrary. They kind of like take a bunch of data over like a 20 to 50 mile radius and say like, okay, this is unwalkable. But we want to see over the weekend if we could literally like put the street intersection of like Powell or like the Civic Center BART station in San Francisco, see how unwalkable or walkable it is, and then literally attach like really nice visualizations of what that exact street intersection looked like if there are more like bicycle lanes or more sidewalks or more benches for people to kind of congregate on. And so Abi will kind of describe more about the technology behind the solution.
Thank you, Chloe. I think the best way to show this to you guys would just be to walk through it. So how many of you live in SF or recognize a spot on this map? Raise your hands. Okay, a fair amount of us. Let's go exploring. So we can pick any marker on this map, and it basically takes us to a location. So this is just Dolores Park. And you can see that this entire map view has a bunch of layers to it. This is what Chloe was referring to. All of these little bike signals are actually data taken from the SF government. They post information in GeoJSON format about where you can park your bikes. So that's an example of like a kind of layer that we added onto this. So it was super customizable. We took this basic map and then added in the bike, parking areas, and then also the heat map representations of where there was the most traffic congestion, as well as this thing called walk score. So walk score comes from the walk score API, and they're basically just like the most trusted API for determining the walkability of a specific like longitude-latitude pair. So we made a unique one for everyone. And my favorite part of this was doing the Google Maps Street View integration. I think this is a really key component to any like urban planner or even just a normal person to understand what a space looks like. You have to be in that place, and if you can't be in it and live like a resident, the best alternative is at least to see it and what it looks like and what your thing would integrate as. So here's our lovely Civic Center Plaza. And then our last little bit here is actually one of my favorite parts is being able to get like super specific suggestions on how this location can be improved. So we used OpenAI's language models and did a little bit of prompt engineering based off of the location and the address, as well as things that we know about the walk score. We basically get 5 suggestions that any urban planner can use to like figure out where they should go if they're going to integrate their own thing into the space. So for example, we think about doing a complete streets approach to the area by narrowing the road widths, making it easier for people to walk on sidewalks. I think like a huge motivation for this is that people need to do more active transport these days, and I think it brings a lot of equity and power back to people who like could be suffering a lot from not having access to public transport, like I am living in Berkeley and not being able to get to SF. Okay, on to Anshul.
So right now we've covered a few different types of pieces of information, right? We have the geospatial location given by the map and also the numerical statistics that we pull from the API. But we're missing out on a pretty important piece of information that could actually help us make even better suggestions to actually how we can improve a specific area to make it more walkable, and that is image data. So I think it's going to be loading up right now, but basically, this part of the pipeline essentially takes in an image which corresponds to a screenshot of the Google Street View when a user actually decides to select a specific view and says, can you like give me suggestions on how I can improve this? And it uses the clip image encoder to convert this image into an embedding representation, which is then compared to a bunch of pieces of text which describe different aspects of the actual image itself. So for example, we have different pieces of text that describe car concentration, like we have a lot of cars, we don't have a lot of cars, we have a medium amount of cars, and we have similar stuff for public transportation and also for pedestrian walk spaces as well. And what this allows us to do is, because Clip's image encoder and text encoder encodes information into the same latent space, we can actually perform quote-unquote semantic search to determine what pieces of text actually best describe this image for multiple different categories, like for car concentration, public transport, and pedestrian crosswalks as well. So using that, we can actually engineer a very specific prompt which we can feed to DALL-E, and that actually allows us to create an image where it's essentially like an augmented form of the original image, where most of the structural information is preserved in terms of like where the city is located is in like a suburban area or like a large city, and very specific things are changed. Like over here, we can see that we don't have any sidewalks in the input image, but we have pretty large sidewalks in the output image because the model was able to identify that the input image doesn't have any sidewalks, and it was able to take that into consideration and actually update that when it actually produced this final image. And if the input image doesn't have, if it does have sidewalks, then the model and the system won't really take that into consideration. So the final image won't like make an already big sidewalk even bigger. It's going to take everything into consideration and output the most walkable version of a city. So yeah. Thank you. Yeah.
Congratulations.
Awesome. We'll just wait a little bit for the screen to come on again. So next up, we'll have our most technically complex hack. So this is the project that basically had the most engineering complexity to it. And the winner for that is Proactive Refresh. I know. Jacqueline. Yeah.
Cool. We are Proactive Refresh. We built Proactive Refresh on top of threshold signatures. So threshold signatures are currently used across a bunch of crypto and finance, banking industries today to protect assets. And the way it works is basically there are a bunch of parties that can sign on transactions, and you need an X amount of transactions to reach a threshold in order for a transaction to go through.
And a lot of times, these private keys are not rotated, which leaves these organizations very vulnerable to attacks. For example, attacks like the Ronin bridge hack. $650 million was lost in that attack, and it was protected through a 5 out of 7 multisig. This is where proactive refresh comes in. We refresh the private keys so that before, hackers would have to decrypt these keys, like let's say 5 out of 7 keys, and they would have basically unlimited time to do this. But now they have to do this in only 30 seconds because we keep refreshing the private keys. We implemented this entire stack, the cryptographic primitive as well as the ZK proofs, from scratch. And to show this a little bit better, we're going to dive into a demo to show how this works. And this is going to be a replay of an attack.
So what we're seeing here is we simulated what an adversarial attack would look like over the course of a few months. On the left here, you're going to see what the industry standard is, and it's a vault without proactive refresh. And on the right, you saw our vault with proactive refresh. And you'll notice that the secret keys on the right kept cycling, and the secret keys on the left stayed constant. So whenever an adversary compromises one of the keys, it stays red, but on the right, the reds go away after every update cycle because the keys are useless. And what would typically happen, and what has happened a lot in industry right now, is the left happens over the course of a few months, you create a signature, you create a proof for it, and then you send it in, your vault gets drained, all the money goes away, everybody's sad. But now with proactive refresh, it wouldn't be able to do that. And so a good way that we like describing this is, it's like if you guys saw Duo Mobile, Google Authenticator, I'm seeing a couple nods, it's pretty familiar. It's as if we did Google Authenticator, but we did it with multiple parties. And it's a lot harder to do it with multiple parties for a few reasons, and it was only enabled in a 2022 paper, a theory paper out of the Bonnet laboratory that showed how to do this, and they didn't implement it. And we didn't kind of figure out why, because when we went in with the implementation, we had to do a lot of things from scratch. So it was a big engineering lift. We did everything from the core cryptographic building blocks. So we started with elliptic curve math, elliptic curve cryptography to build the BLS signatures back up again, which needed pairings and operations and math across different fields and different groups. After that, we also implemented proactive refresh on top of it, which constructs polynomials in these specific ways so the updates and the cycles can happen. And we also worked on accountability, which is this thing called Shamir secret sharing scheme. And all of that was a bunch of jargon, but with what we have right here, we had a cool cryptographic primitive, and we thought it was a better way to do special signatures in general. But we know that people don't care about just primitives. Like, you have to build something end to end, you have to make it easy to use, and you need to build something that people care about at the very end. So we built something full stack. So off of our primitive, the first step was making it easy to use. We did that by wrapping it in a ZK proof, so it's really easy to throw around. And you guys can check our repository for more details on this. I won't dive into it. But then I want to get more to our application, where we use the primitive, and we use the primitive that we made easy to use, and then built something off of it.
So we've got this first of its kind new digital signature algorithm. And the application we chose was to launch a multi-signature vault on Zeta Chain that instead of using the standard Gnosis safe code, we've swapped out the signature algorithm to instead use our signature algorithm. So what happens, instead of a standard Ethereum elliptic curve digital signature being verified, a user who wants to execute a transaction on this multi-sig will instead send in a ZK proof of the BLS signature generated by this multi-party signature algorithm into the contract, and then the contract delegates verification to a ZK proving contract, which then executes the transaction. So this is like a completely novel signature verification algorithm for Gnosis Safe, and we took advantage also of Zeta Chain's multi-chain features. So you can actually submit transactions from any chain that's supported by Zeta Chain, including Goerli or Polygon Mumbai. And when you submitted a transaction to one of these side chains, an event will be launched. You can see the event data up there with all of the execute transaction data that should be forwarded over to Zeta Chain. And then the vault, that code is run, that call data is run in the vault on Zeta Chain. So we've got this one single vault that handles like all the asset management, and it handles all the signature verification, but that vault can be called from any chain and can also deposit and withdraw to any chain.
Okay, that was a lot. So just to recap what we did this past weekend. One, we created or implemented a new cryptographic primitive library using Rust. Two, we made it really easy to use using ZK. And three, we built an application on-chain. But proactive refresh isn't just limited to on-chain applications. We can also extend this to enterprise. So think about when like internal hacks happen on like platforms. You might compromise the keys of like a single employee, and then you have internal access to all of their sensitive data and whatnot. Here, we can actually distribute trust between multiple parties using proactive refresh, and also make it super duper secure using these cryptographic primitives and within very, very short time intervals. So yeah, I think that's power of cryptography.
Thank you so much for that.
Thanks, guys. Appreciate it.
Thanks.
Oh yeah. All right, so for our next prize, we have Best Hardware Hack. So the winner of this is Smart Shoe.
Hello? Well, that is loading. What we did is we made a navigational smart shoe accessory that you can clip onto your shoe, and then it has sensors equipped so that it can detect obstacles in your way, and it will vibrate whenever it detects an obstacle. So it's for the vision impaired people, so when they cannot see, like the people who are slowly adjusting to being blind, who are naturally blind, they can easily clip this thing onto their shoe, and it will navigate them and tell them which way not to go. So let me select this. All right, right now the LED looks blue. That means it's on a flat screen and it's like you can use it. And the motor here, I will hold it with my one hand, and if I put a hand in front of this sensor, it will vibrate. And the LED will turn green, which tells you that this is not the right way to go. It's very sensitive, so it almost goes like right on. This is an ultrasound sensor, and we have an infrared over here as well. The ultrasound sensor goes really long. It can go up to like 4 meters. And the infrared is a little smaller. It's like about this long, because on the sides, you're not that likely to hit something. We are powering this entire thing with two 3.7 LiPo cell. Because our hardware requires different voltage input, we had to make a regulator, and we had like 7-volt input, and then the regulator puts it to 5 volts, and then each hardware components require different voltage, so we have to regulate it for every single component. So we have an ultrasound at the front and IR proximity on the side. And what's cool about this is that it will only detect the surrounding area when it's flat on the ground. When you're like walking and in motion, the LED will turn red and it will not detect it until you're on the ground, and they will turn back to blue. So if you made a wrong step, for instance, it starts vibrating. It will keep on vibrating until you're in a clear area where there's no obstacles in your way. So like, let's say that it's vibrating right now because something is in front of you. And then you will have to like turn and find the right direction until there's nothing in front of you, and then you're safe to walk again. We have a video of it when it's assembled, which might be clearer if people in the back cannot see. And if you're moving, it will be red and it will not sense. Yeah. All right, I think that's it.
Thank you. The 3D printer's a little big, so it's outside, so you'll be able to grab it after.
Thank you.
Awesome.
I have a teammate.
Yeah, sorry, both of you. Yeah.
Awesome. So our next prize is our healthcare grand prize, and the winner for that is Health Story.
Is Health Story here? Oh.
Speaker notes, or is that not going to work? Oh, they can.
Everybody has their own personal story, and it's really, really difficult to know everyone's personal story, whether that be their medical data or what they do at home for fun, or what they eat, what they do for exercise. It's really hard to gather all this data in one place and really personalize healthcare, which is a really large issue, in fact, because there is a large amount of medical errors.
250,000. That's the number of deaths that's caused by just pure medical errors every year just in the United States. That's number 3 reason behind heart disease and cancer. Surely we can do something to reduce the amount of errors in United States. So what I mean by medical errors is what happens is during a conversation between a patient and a doctor, a lot of the times the doctor misses out on important details of the conversation because he has to focus on a lot of details. Does he focus on the patient or does he focus on taking notes? A countless number of hours are spent by doctors as well as nurses in taking notes and in making incorrect inferences. This is the problem that we are solving, that we want to take away time from the doctors and nurses for taking notes to actually giving care to the patient. And we want to take the responsibility of the note-taking part to ourselves. So our app named Health Story does exactly that. It provides a comprehensive evaluation of past medical history of the patient, ranging from their medications, ranging from the allergies that they have, along with a live transcription of the patient and the doctor conversation, which then summarizes onto a medical soap format, which we will now explain.
Yeah, before we go through that, I'd also like to explain hypertension, which is the medical illness that we wanted to focus on. And this is just because it is the leading cause of death, and it is the primary or contributing cause of a lot of other diseases, and it is not under control. And the info needed to treat hypertension is actually very qualitative and not quantitative. So it's really difficult to get all this data without getting it from the patient themselves. And as my as my teammate mentioned before, these are things that doctors want. They really want all the metrics in one place. They want to know what they don't know about their patient, whether it be correlation from your heart rate going up and the fact that you really couldn't get transportation to get to your medicine. So, and medical error in that case would be, for example, the doctor would prescribe you twice the dosage, which is not something we want at all. We really want the correct treatment for all patients, and that's, I think, like, as the patient yourself as well, that's what you want. As well, you would also want to know as a doctor, like, what tests were ordered and the reason that you had them. And a lot of doctors, yes, they have that information, but you're going to be sifting through 20 files, 30 files. And think about this, like, how many patients do you have, and how much time do you really have to sift through all these files? You don't. In fact, we talked to one of the doctors here, and they said to make a diagnosis, they really only have 20 seconds. We want to give this all their data in 20 seconds, as much as we can, so that they can give a proper diagnosis. We also have some other features that we did, such as a chatbot. So if they wanted to ask any questions about their patients, they're able to, and it would be catered towards their personal data. And they'll have SOAP, which we'll explain in a bit. And we'll also have reasons for, like, why patients are taking certain drugs.
Yeah. So the first thing we solve here is about making the interaction of a doctor and a patient just more natural. So nobody would like to see the doctor kind of jotting down notes as you're speaking with your patient. I think doctors want to make the relationship with their patient more natural, and we help them do this by taking away all of the load of note taking. We heard that if a doctor is working for 12 hours, 6 hours of that time is actually spent in just managing all of these notes. So we built a system which would just take this transcription and kind of generate notes into SOAP format. So SOAP is, this full form of SOAP is subjective, objective, assessment, and plan. So we kind of just generate all of these notes just using GPT-3 API on top of a transcription of the patient conversation. We also show all information that you need when you need it. We plot all of the metrics that a doctor might be interested in, like your blood pressure, ECG metrics, all of those kind of metrics, as well as if something spikes, why did that spike? We sift through all these SOAP notes, which might take a doctor a lot of time, and bring all of those insights directly to you. We build an API which just takes a conversation between a 2-minute conversation, for example, between a patient and a doctor, and just builds these notes and kinds of summarizes all of the notes that kind of summarizes all of these notes in a way which is useful for the doctor. We did a lot of user research and talked to a few sponsors and kind of doctors and nurses, and we're really thankful for their help. Paul Tang helped us kind of think about, understand from doctor's perspective what kind of problems there are, and yeah.
Congratulations. All right, so up next we have the Sustainability Grand Prize, and that is going to ShipSense.
Hello. Yeah. I'll be like, oh, here's the time.
Who's moving this slide?
Wait, one of us should just stand back there at all times. Ready?
Sure, should I hit the first slide, please?
Just wait until I'll introduce it. Just rub your. Okay, perfect? Okay. Hi, guys. I'm Molly, and this weekend we built ShipSense, which is essentially mitigating overfishing with AI-generated synthetic satellite data. First, let's introduce the team.
Hey, I'm Andrew. I'm a freshman at Stanford, and I'm really active on Twitter.
Hi, I'm Soham, also a freshman at Stanford.
Hi all, I'm Shayak. I'm a senior at Harvard.
Hi, guys. I'm Molly. You guys, I don't know. I'm a sophomore at Stanford. Super excited to be here. And yeah, we're trying to keep this as casual as possible and hoping to reel you guys in. So, the problem space is that half of the world's fish population has depleted since 1970. What this means is that we no longer have plenty of fish in the sea, and this is a tremendous problem. So essentially, us as developed nations are fishing the nations that are, not having access to the same sorts of resources, being able to. I'm sorry about the delay. But essentially, we have a problem, which is that this is a continuous battle between big and small, wealthy nations and underdeveloped nations, which creates an inequality with the types of people that have access to, the most powerful resource in the world, which is water. So essentially, what we look at is satellite data and satellite detection, and try to see, using AI, whether we can empower governments and under-resourced governments to actually take action towards these insights.
Thanks, Molly. So if you want to train an AI model to detect shit from satellite imagery, you're going to need a lot of data. And so currently, we have about 2,000 labeled images of boats from satellites. But anyone who does ML knows that that's not nearly enough data. And there's ways to amplify this data using GANs, generative adversarial networks, but you generally need around 50,000 training images to get any good results, and that's a low estimate. So what about using Stable Diffusion? Stable Diffusion is an AI image generator trained on billions of image text pairs. It's great at making realistic images. It's like ChatGPT or GPT-3 for image. And just like GPT-3 can be fine-tuned, why not Stable Diffusion? Instead of needing 50,000 images to train a good image generator for synthetic boat data, we use 68, and here's how. We obtained 68 images, sized them to 512, 512, did classical data augmentation by rotating and flipping, and then we fine-tuned a Stable Diffusion model and asked it to generate real images. It takes 1/1000th the data you need for GANs and is 10 times faster. And don't just take the word for it. Take a look for yourself. We're going to have a little captcha game real quick. If all of you in the audience can raise your hand if you think the left image is a real image, or the right image. Ugh. If you think the left one is the real one, raise your hand. Okay. If you think the right one is the real one, raise your hand. So what if I told you these are both generated by our AI, which again was only trained on 68 real images. Next slide, please. Here's some other of our synthetic data. Great diversity of boats, different boat types, sizes, different watercolors. And that's the kind of data it was trained on, so we're able to actually enhance the resolution.
Yeah, and one of the big challenges here is class imbalance. Like you look at the sea, you see a lot of sea, not that many fishing boats. So that makes it really hard to train a CNN to do this task accurately. However, with our novel data augmentation methods, we're able to resolve this class balance and achieve 96% accuracy in detecting boats.
No, use this one. We'll just go to the website.
We're going to pull up the demo right here. So now let's talk about the customer-facing end of this application. How can we empower underserved governments to take back control of their fishing waters. Now, if I'm a local government, I don't speak English, then I want to have this dashboard translated to whatever language feels most natural to me. So that's easy, it's with a click of a button. Next, we built a geospatial data analysis platform to enable local governments to track, analyze, and take action on clustered regions of overfishing hotspots. This dashboard enables local governments to identify the what, where, and how of overfishing. For example, if I'm a local government, if I'm a national government in West Africa, I can understand exactly what latitude and what longitude this cluster of overfished regions is, and I can analyze exactly which fish are being driven to the brim of extinction. I also have access to raw satellite images, and we use LLMs like GPT-3 to generate context-aware recommendations for how a country might consider responding to this overfishing problem. So the way West Africa responds would be very different from the way Brazil or India responds, and we want to make sure to take those differences into consideration. Now, in order to actually take the next step and take action, we've implemented a really easy to use export to PDF feature that enables us to export this to the local Coast Guard agency and have them enforce. So with designing this customer interface, making sure that it was accessible to end users who might not have experience with artificial intelligence was one of our thesis points, and we wanted to make sure that it's as accessible as possible to everybody.
Great, thanks, Soham. And just to get into getting away from all the fish, getting away from the boats, we think this is a really interesting method of using stable diffusion to generate synthetic data. Because throughout the history of AI, the big thing has been you need data. Scale AI makes tons of money from data. Everyone's talking about GPT being trained on 45 terabytes of text data. But what if you're like the little guy? You got like maybe 50 pictures of a cancer cell. You got 100 pictures of a diseased lychee, right? Which ResNet 50 doesn't work for. This stable diffusion model enables you to take few amounts of data, amplify it with stable diffusion into diverse data sets, and then train an object recognition model on any object you want. This has massive implications in medicine, agriculture, defense, and more.
Yeah, so we create impact by transforming maritime policy and essentially transforming the way that international relations impact the most powerful resource in the world, which is water. And the way we do it is in a uniquely technical, but also a uniquely social oriented way. So this is ShipSense, and this is what we built. And we're super excited to share it. Let's.
Congratulations. Your prize, the projectors, you can check with our team outside about that. I think they might still be in transit.
Awesome. Just a few more prizes here. Our next prize is going to be our New Frontiers Grand Prize. This is basically the best AI, ML, VR, cutting edge tech project. So the winner for this prize is Articulab.
All right, so this is Articulab, and in a sec we'll get into all the details on how it works and what we're hoping to do. But while they set up, would you guys like to be in my B-reel? Because it just went off, and I think it'd be a really good B-reel. So like, if you guys can smile for me, for the camera. Oh no, there's no screen. Oh well. So yeah, B-reel, cool. Okay, well, Cam here is going to introduce Articulabs for you guys.
Hello, my name is Cam. These are my teammates. This is Nico, Josh, and Ryan, and we made Articulab this weekend. So Articulab is basically our attempt to make public speaking training more accessible to everyone. These are artistic choices. So essentially what we do is that we hope to be able to give real-time constructive feedback and criticisms to people who are looking to practice their speech and debate skills within this VR experience. We hope to be able to bring we hope to be able to bring to people the ability to improve in a controlled environment so that they are able to bring this into the real world and have the confidence to express all the ideas. So, is Ryan doing it? Is Ryan doing it?
I can do it. Do you want me to demo it? Okay.
So these are one of our customizable features as well. You are able to choose your own audience, choose your own debate partners. These are just artistic choices that we decided to put in at 4 a.m. yesterday. Yeah. So what you're seeing right now is exactly what Nico is saying. These are our audiences, and in front of you is a little podium. And so what is going to happen here is that we are going to give you feedback on your speeches in both content and style. Let's look at style first. Okay, let's say Nico is speaking, but he's really shy, so he's looking down at his feet a lot. What's going to happen is there's going to be a message saying, don't look down so much, look up. So Nico's going to look up, but now he looks up too much. It's going to say, don't look up too much. And now Nico's really nervous, so he can't make all the hand gestures that he should. So he's like, he's just crouching like this with his hands together. It's going to say in a bit that, don't keep your hands so together over there. Move around a little bit. So this is what we track. We track your demeanor and your attitude as you're speaking in order to detect whether or not you're being nervous or you need to practice on your confidence a little, and we give you this real time so that you can improve as you speak as well. In terms of content, this is really easy. So everything you speak will be debated by our fellow SpongeBob over here, who's your debate opponent. SpongeBob is powered by ChatGPT, and we use text-to-speech API in order to power up this SpongeBob. So does anyone have a really controversial opinion they'd like to debate against SpongeBob? Yeah?
Pineapple pizza.
Okay.
The best condiment on pizza is pineapple. Pineapple is not a condiment.
Counter argument. The best condiment on pizza is actually sauce.
Well, it picked up on my mistake, so. And then you can keep the discussion going. For example, like I could say.
Speak clearer. What are you referring to?
I could say, give me examples of the condiments you mentioned.
Counter argument. Common condiments include ketchup, mustard, mayo, hot sauce, sriracha, and relish.
Not pizza. Sorry, like not pineapple. Oh, right. Articulab will also pick up when you stutter and can't finish formulating your sentences the way I was doing like just a little bit ago. So here's an example of that. I'm going to go ahead and press this button. And I don't eat.
Speak clearer.
There you go. And do you guys want to add anything? That's about it. Oh yeah, that's Articulab.
Yeah, thank you.
Was I looking the wrong way this whole time?
No, you're looking at me.
Okay.
That was awesome. Thanks.
Thank you.
All right, so our privacy and safety grand prize winner is Ally. And sorry guys, we know we're running a little over. We're almost there, just a few more prizes left.
Hey guys, while this is booting up, I think we can introduce ourselves. I'm Catherine, I'm a junior at MIT.
I'm Alan, I'm a senior at MIT.
I'm Anna, I'm a senior at MIT.
Mindy, I'm also a senior at MIT.
During this hackathon, we worked on Ally, and our mission was to save lives with drone data. Is it working? And the problem that we wanted to focus on was that tens of thousands of people are dying every year in natural disasters due to poor infrastructure. We're focusing specifically on earthquakes during this hackathon because they're the deadliest, and in light of recent events. These earthquakes are extremely deadly because these cities did not enforce building codes and did not treat safe housing as a human right. Construction companies have been cutting corners and ignoring building codes for decades, and the government often just lets it slide by.
Right, so our solution is essentially a bunch of companies are releasing drones that already move well autonomously and output a lot of good data. However, the teams that are using these drones and receiving this data aren't very technically advanced, and so there's a very long convoluted workflow to process this drone data. So our solution is an automated workflow for drone data management. For example, these companies or these individuals can drag processes that they want to add to their to use to automate their current data management.
We did a lot of research, and one of the papers we found was from the American Red Cross. They highlighted that there are a lot of very powerful drones companies already, but it doesn't really mean much if people aren't able to process their data well. So right now, their customers are often forced to come up with their own systems to process their data, and it's not very streamlined, and it's also very hard for non-technical users. So I think we're going to give a demo now.
Give us just one moment. Okay, so over the course of the past 36 hours, we built kind of an MVP for how this will work. Specifically, you can go try it out now. The first thing that happens is you can select a project to kind of double click on. This is essentially just a data set of images that we uploaded ahead of time. We can always add images if you want to. So an example of how that happens is a really simple upload image. This is if you have any drone footage that you want to analyze or search from, you can just upload and give it one moment. I know everyone's on the Wi-Fi. Sweet, there it goes. And then the following step is you can query these images. So let's say you are rescuing people in an earthquake, in the aftermath of an earthquake, and you're searching for man under rubble. So this brings up the top 9 images most relevant to your search. And in fact, this search has gotten so accurate that if you search for something as niche as man in yellow puffer or a guy in a yellow jacket, the first image that comes up is a picture of a guy in a yellow jacket. Finally, an example of a search is, let's say, flooded streets or something. This will show flooded streets. So what's actually happening behind the hood? I think another team has mentioned this earlier. We're using Clip. What this means is we're taking text and images, and it's really hard to connect these just abstractly, oh, how are you supposed to connect pixels with words? And OpenAI's Clip model kind of takes both these mediums and kind of maps them into vector points. And the vector points that are closer together are actually closer in meaning. So if a word or if a phrase is closer to an image in distance, it means that they're more closely related. And that's how we're sorting.
Yeah, so obviously this is an MVP to show the capability of the querying images, but in the future, what we want to work on more is to allow any type of user, including government officials, construction workers, or park rangers, doing a variety of tasks from disaster relief to figuring out where to cut costs in construction or search and rescue in national parks, for example, and then they could, then they can customize their workflow and drag and drop different tasks into the workflow so that they can process their data and use the data to a maximum capacity. Right now, what happens is government officials might take hundreds or even thousands of volunteers to manually skim through videos of drone data in order to find, like we said, like people under rubble or for search and rescue efforts. And so we would do all of that processing in hours, if not minutes. Thank you. That's Ally.
Congratulations.
Thank you.
Is this me or you? All right, so next up, we just have one or two more and then we're almost done. So next up, we have the Web 3.0 and FinTech Grand Prize. And the winner of that is Domi Rental Companion.
All right, what's up, guys? I'm Pun.
I'm Chelsea.
And I'm Karen.
And I'm Peter. And we're Domi, an application to make renting much easier for landlords and tenants. I'm sure you all know renting from landlords and tenants is a very complicated process. You have to pay through various different payment channels, from Venmo, Cash App, to sometimes even checks or cash. So we wanted to aggregate all these payment processes and have it in one app so people can actually manage these payments much easier on both the landlords and the tenant side. So the market for rental units in America is 20 million, and 45% of those landlords manage their own property. While these numbers are great, I have some anecdotal experience with my roommates back in San Diego, and we noticed a very big problem with how we were managing our payments. We would be aggregating them every single month, and they would be scattered because some people would be forgetting or some people couldn't pay it that month. And it just made the whole process so much more complicated and such a headache for us. So we wanted to aggregate all these payments in one place so that, one, the tenants can actually go on with their lives and not have to worry about other people's payments, and two, the landlords can actually have some transparency and some visibility into how each person is actually conducting or contributing their payment towards the total rent. So the first problem we're trying to solve is fragmented payments. Basically, just like I said, aggregating all these payment channels in one place. And the second is communication, which is regarding various things like maintenance, as well as specific clauses in leases and any policies that specific landlords might have for their properties. So yeah, like we said, we want to make life easier for landlords and tenants. And essentially, the features that we want to provide are basic cash flow management, so aggregating all transactions in one place, have some property management tools, so be able to file maintenance tickets and create issues very easily. And then finally, DomiBot, which leverages LLMs to basically provide a natural language assistance to essentially talk about your lease or describe your lease to a tenant in non-legal terms and very easy to understand terms. And on the tenant side, again, there's DomiBot, but there's also just a one-click payment, so you don't have to go through all the process of various payment channels. And for the demo, we're just going to show a video. Essentially, this is our bot. So our friend right here, she has a dog at home, and I don't. So I was wondering whether my lease was or my lease permitted dogs in the apartment. So I would go up to DomiBot and just ask whether I can have some dogs in my apartment. So this LLM is actually trained on both the lease. So we parse the lease as well as it has information or has access to information on the open web. So it basically uses all that context with the lease to kind of give me an answer. And Jonathan actually does not allow pets, which is sad. And yeah, that's it. And thank you guys.
Okay, we're not going to bother plugging the computer into the screen because it takes a while. But our education grand prize winner is Zazu.
Hey everyone, hey everyone, we're 5 UCLA students studying CS, and we're 4 UCLA students studying CS, and we made Zazu. It's I know a lot of you have experienced online learning, and I can confidently say that it's not engaging, and we aim to combat that with Zazu. It can answer student questions, generate practical exercises, and summarize lectures in real time. So yeah, I'll let you do that.
So I think the easiest way to show the product is just to walk through a demo. So I'm going to be the teacher, and my friend Jeff here is going to be the student. So let's get this started. So first I'm going to join the lecture. I'm going to mute myself. And yeah. So basically what Zazu does is that we basically take a real-time transcript of the lecture and we feed it into OpenAI's DaVinci LLM and we get responses from it. So one of our core features is basically we're able to generate real-time quizzes based on the lecture thus far. And I think I'll just show you how it goes. So I'm just going to give a short lecture on the NFL. I'm just going to say keywords because we don't have time for a real actual lecture. So. NFL, Super Bowl, AFC, NFC, 17-week season, playoffs, right? So I gave it a little blurb. Zazu, generate question. Zazu, generate question. Okay, cool. Yeah, so now it's going to generate a question based on the transcript of the meeting thus far, and it's going to send this question to basically everyone in the meeting. So this was supposed to do it on the NFL, but because I unmuted myself right before it got the last aspect of what I was talking about, so I was a little confused. But so basically, it's going to do a real-time question based on the transcript of the meeting thus far and send it to everyone in the meeting. So we can say that's a question. And then we also have support for chatting with ChatGPT built in. So if a student has any questions or any issues with the lecture and they want to Google something, they can instead do it inside the meeting itself, and they never have to leave so they don't get distracted, and increasing the efficiency of these online video lectures. Another feature for teachers is that if they feel like they can't catch up with the students, is they can ask Zazu, am I going too fast? And then it will pull all the students about what is the speed of the lecture, and all of this is brought up by voice commands. And then, so these are the main feature set, and then the other main feature is that after you leave the meeting, we auto-generate a series of notes using our summarization features, and this will basically give the students a series of notes so they don't actually have to take notes of the lecture and can focus on the lecture itself. And we also have a series of questions that come up at the end to basically check your comprehension.
right. Just as a closer, I guess our next step would be to add this feature to pre-recorded lectures because, there's no one there to help you, but Zazu will be there. So, yeah.
All right. This is our last prize and our biggest prize. So we'll plug it in for this one. So our moonshot prize. Yeah. So our moonshot prize, which is the most out of this world project that we saw at TreeHacks this year. The prize is a electric scooter, $1,000 electric scooter, one for each team member. The winner of this prize is
Drone Former.
Let me know when you see it. Yeah, just make sure. Perfect. All right. I love you, Kevin. All right, so I'm sure a lot of you have seen the news recently. There's been a 7.8 magnitude earthquake in Turkey. 84,000 buildings have been crushed to rubble. And there are millions of people potentially trapped under all of this. How do we go about finding them? The 36 hours after a disaster occurs is most important because that's the amount of time that people are most likely to be alive after a natural disaster. And that's the same amount of time as this hackathon. So drones actually are a fantastic solution for searching for people here. They can fly above, they can use a bunch of different sensors to look at the entire site and see what's going on. But drones are also extremely hard to use for emergency responders. You either have to control them remotely or you have to write code. And emergency responders, after natural disasters, have time to do neither of these things. So what do we do here? Hi, my name is Brian, and I'm currently a student at Stanford. I'm joined by my teammates Sid, Joanna, and Michael. And let me introduce you to Drone Former. We're developing a way that makes controlling drones and letting them do very complex tasks as easy as just telling it a natural language command. And this really paves the way for prompting robots to do more and more complex things using natural language alone. Let's go through a sample task. For example, let's say we're back in Turkey and we want to send a swarm of drones to survey disaster sites to see if there's anything that could be done and how rescuers should be able to help the victims. So what we do here is instead of coding every single drone in the swarm, what we want to do is we want to tell it a command. Fly over these sites, survey the entire site, and count the number of people who need help and count the number of rescuers we have. This is not only important for discovering the people who may still be missing, but it's also incredibly relevant for emergency rescuers as they distribute their resources. You definitely don't want to be doing this by coding. There's way too much errors that could potentially occur. There's not enough time to test the system appropriately before actually deploying it. And that is Drone Former. On to you, Sid.
Cool. So I'm just going to talk a bit about how this all works and how this comes together. So basically, we built out a set of primitives that could take text as input. These primitives basically allow you to control the drone, such as move forward, turn left, but also allow it to use a camera, such as detect object given a label. With these primitives, we basically built out a monster prompt where we list out all the primitives and describe what they can do and what the ranges of inputs they can take. We describe a list of constraints about the primitives and the environment. We give it the high-level objective, and we do some few-shot examples so that it knows how to sort of respond. And with that, we generate a Python script that accomplishes the high-level objective, and we run that script on the drone. Yeah, cool.
Sure.
Yeah, so I guess I'll talk a little bit about like beyond the material applications of this, what does it mean in the research space? So I guess Joanna and I, for like juniors at Princeton, we do like NLP research. We're like not involved like the building as much as the building the models, right? So I guess like I think there are two key points to get from this. What we've essentially built is a way to take models that are good at image understanding and models that are good at long-term planning and put them together and basically take all of the fine-grained work out of drone automation in the same way that large language models have taken the fine-grained work out of writing text, or image models have taken the fine-grained work out of doing the minutiae of illustration, right? And so I think there's two takeaways here. We're essentially combining two breakthrough technologies. One of them is models that have really powerful image understanding. So the composability of our model, which mostly uses YOLO right now to do object detection, can be easily extended to things like VLOT, BIET, these really large multimodal models. And essentially all that needs to change is we need to create a new primitive that the code model can then use as a function to be called. So right now we have in our prompting a function called like object detect, which we describe in natural language, takes in some string of an object class, and then returns some like bounding box with some parameters that the code model then knows how to use. All you need to change to take in a new state-of-the-art release of a new visual language model, let's say a new VQA model, it would be to describe a simple API and put in what it takes in, what it comes out with, and immediately your model inherits all of, the process inherits all of the new capabilities of the model. The second one is code models. So as we've seen with releases like Codex and DaVinci, which is essentially a fine-tuned version of OpenAI's code models built back into the language context, we're able to utilize long-term planning, and essentially this turns simple natural language high-level instructions into thousands of lines of long-term detailed instructions. So here we're about to show a demo here where we essentially give the prompt of just 3 words, find the bottle, and it turns it into about like 30 or 40 lines of a code of primitives using the Tello SDK, which includes basic movement and our object detection.
Yeah, now that you've heard about the model, let's see how it works in practice.
Yes, with our sponsor, aside from OpenAI and the drone Tello, we are proudly sponsored non-officially by Picari Sweat, which is the objective this drone's mission today.
Objectively the best string ever. Drone former. Go for the bottle, but not for the cloud. There you have it. Drone former. Control any drone and any robot using natural language.
Okay, awesome. Our last announcement is that Aspecta is a sponsor, and they're going to be holding a hack night event right after this with free food and beverages, some special guests. So while you're waiting for your bus or if your flight is later, please go hang out with them in Huang 18.
Yeah, lastly, we just wanted to say thank you for coming to TreeHacks and spending the weekend with us. We hope you had a great time and got to make an amazing project. Thank you to our entire organizing team, our head of tech, Safik, our head of social marketing, Rohan, our FO, Ramsey, and all of the saplings. Thank you.
We'll see you next year, 2024.